In this video, we'll do some examples of 3x3 linear systems that present as application problems or word problems. So when we solve a 3x3 system of equations, which we covered in the previous example, you can solve using substitution or elimination. And to get started, what we always want to do is write what each variable represents, and then we're going to interpret our answer in a complete sentence, and we're always going to make sure to include our units. So when we write our equations, we want all of the equations to be written in what we call standard form, which is ax plus by plus cz equals d, where a, b, c, and d are just numbers. So here is our first example. 1 8-ounce serving of brewed coffee, Red Bull, and Mountain Dew soda contain 197 milligrams of caffeine. One serving of brewed coffee has 6 milligrams more caffeine than 2 servings of Mountain Dew. One serving of Red Bull contains 37 milligrams less caffeine than one serving each of brewed coffee and Mountain Dew, and we want to find the amount of caffeine in one serving of each beverage. So we're going to start here by identifying what our variables are. So what we want to know is how much caffeine is in one serving of each beverage. So we're going to say the caffeine in one serving, let me say that, of, and then we'll just write all three of these. So we'll say for Red Bull, we'll call it R. For Mountain Dew, so this is caffeine in one serving of Mountain Dew. And for our coffee, we'll use C, and again, that's caffeine in one serving of coffee. And I'm going to go ahead and read my problem again so that I can think about my equations. 1 8-ounce serving of each, so that's coffee plus Red Bull plus Mountain Dew, contains 197 milligrams of caffeine. So that's our first equation. Our second equation, we say 1 serving of coffee has 6 milligrams more than 2 servings of Mountain Dew. So our coffee is going to be 2 servings of Mountain Dew plus 6. And for our third equation, 1 serving of Red Bull, R, is 37 milligrams less caffeine than 1 serving each of coffee and Mountain Dew. So we'll say coffee and Mountain Dew, and it's 37 milligrams less. All right, here's our system, but one of the things that we said previously was that we want these all lined up so that all of our C's are lined up, our R's and our M's. So I'm going to start with C plus R plus M equals 197. And then I'm going to make the second equation C 0R, because we don't have any R's, and then minus, I don't want to write 0R, I'm just going to put nothing because it looks like or, so plus nothing, minus 2M equals 6, and then I'll subtract the C and the M on this one, and I'll get minus C plus R minus M equals minus 37. So here we have our equations. I'm going to label them A, B, and C. Now you might notice that because I don't have an R value in this middle equation, I would like to eliminate the R in the other two. So I'm going to multiply my bottom equation, C, by -1. That's going to give me C minus R plus M equals 37. And then I'll just write down A again, which is C plus R plus M equals 197. So adding these together, we're going to have 2C plus 2M equals 234. And then we'll just bring equation B over here as well, which is C minus 2M equals 6. And how convenient, when I add those together, I get 3C equals 240. So C equals 80. So I now know how many milligrams of caffeine in one serving of the coffee. I'm going to plug it in here to find the Mountain Dew. So that will give me, and I'm going to start back over here, 80 minus 2M equals 6. So minus 2M equals minus 74. So M is 37. And then I'll use my M and my C in one of the original equations to find R. Actually, I'm going to use this equation because it's already solved for R. So we've got R equals 80 plus 37 minus 37, which is just 80. So let's now answer the question. The milligrams of caffeine are 80 for coffee and Red Bull and 37 for Mountain Dew. All right, let's take a look at another example. In this example, we see that Sam receives $126 per year in simple interest. The formula for simple interest is here. Part is invested at 2%, part is invested at 3%, and part is invested at 4%. There's $500 more invested at the 3% than the 2%, and the amount invested at the 4% is 3 times the amount invested in the 3%. Find the amount invested at each rate. So notice that everything is given in terms of the 3% value. So I'm going to make myself a chart. Now the reason that I've done this is because I have this formula and I have different amounts invested in the 2%, the 3%, and the 4% accounts. And it's going to just help me keep my information organized. So the principal is the amount that I'm investing in each account. And so I'm going to call this X, this Y, and this Z. Okay, and I chose Y for the 3%, so we're going to think about that when we're writing our equations for the others. The rate has to be as a decimal, so 0.02, 0.03, and 0.04. And the time is 1 year, so 1 for each of these. So if I fill in my table for interest, principal times rate times time, I get 0.02x, 0.03y, and 0.04z. Okay, so now let's look at the statement again. We have $126 per year in simple interest. So that means if I add the simple interest from each account, I will get 126. So that's one of my equations. Part in each account, and we have $500 more in the 3% than the 2%. So I'm going to say that the 3% account, which is Y, that amount is X plus 500. So that means that my 3% account is going to have $500 more than my 2% account. And then it says the amount invested at the 4%, which we called Z, is 3 times the amount in the 3%, which was Y. So here's our system of equations. We've identified our variables in this table here, and now we would like to solve. So just like before, I want to write these in the standard form, and I'm going to write them in XYZ forms. So take a moment and do that. You can pause your video and check. Now I notice that this first equation and the third equation have a Z, but this one does not. So I'm going to label these equations A, B, and C as we have been doing. And I'm just going to multiply C by negative 0.04 so that my Z's will go away. So I'm going to rewrite A, and then I'll multiply C by negative 0.04. That's going to give me 0.12y minus 0.04z equals 0. And adding those together, I'll get 0.02x plus 0.15y equals 126. So I now have this equation, which I'm going to call D, and then this middle equation, and they are both in x's and y's. So if I put those two together, let's write down B again. Minus x plus y equals 500. And D, which is 0.02x plus 0.15y equals 126. And I want to eliminate something. I'm going to eliminate the x's. So I'm going to multiply B by 0.02. So negative 0.02x plus 0.02y equals 10. And then positive 0.02x plus 0.15y equals 126. Those will add to 0. 0.17y equals 136. Dividing by y here, 0.17, we get y equals 800. So we can now plug this back in here. So remember, we're at this point right here. We found a y value. We're going to plug it back into the system of 2. So I'm going to use the top one because it's nice. I've got minus x plus 800 equals 500. Minus x equals minus 300. So x equals 300. And then lastly, we'll plug our x and our y into one of the equations to find z. So I'm going to use equation C. Minus 3 times 800 plus z equals 0 minus 2400 equals minus z. So z is 2400. So we can now answer our question in a sentence. Sam invests $300 at 2%. Y was 800, so $800 at 3%, and $2,400 at 4%. So when you get to the next section, which is about matrices, we will learn how to solve these systems not using elimination, but using something called a matrix.